Hello and welcome to the Havering Online Futures Week Subjects Taster in Computer Science. My name is Clifton. I am a curriculum ambassador at the University of East London, and I'm currently going for my master's degree in computer science. And today we're going to learn more about what is computer science. So our objectives for today, 1 is to have a better idea on what computer science is about. 2, to understand the potential of computer science today. 3, to have a better understanding of the career paths computer science opens up to you. 4, to learn the best and worst things about being a computer science student. And lastly, to learn entry routes to be a computer science student. So first, a little bit about me. I am from the United States. I was born in Boston, Massachusetts. I received my first degree in physics at Brandeis University in Massachusetts. Then, after I received my first degree, I moved to New York City, where I was a secondary school physics teacher at the New York City Department of Education. And while I was a teacher, I grew to really like computers, not just how to use a computer, but also how computers can be used to solve everyday problems. So last summer, I moved to London, and I'm currently studying at University of East London, where I am going for my master's degree in computer science. Okay, so my first question for you is, what is a computer? So I'm going to pause for about 20 seconds and come up with a possible definition is, what do you think a computer is? Okay, so a computer is an electronic device that stores and collects information and performs calculations based on a set of instructions provided by you, the person who uses the computer. Now, my next question for you all is, which of these do you think is a computer? Okay, so both of these are computers. So the item on the right is a computer. So many new computers do not quite look like this, but not too long ago, this is what computers looked like. They had a separate monitor, a separate keyboard, but this performed all the same things that new computers use. And to your left, you have a smartphone. So whether you have an iPhone or an Android, this also acts as a computer because you can give it a set of instructions, and you can also use it to, in addition to calling your friends, you can also use it to check your email, surf the web, go on YouTube or Spotify. Now, are these computers? So we have here a smartwatch and what looks like a coffee machine. So technically, these are computers in that a smartwatch is very similar to a smartphone where you can use it to access apps, and it also records information such as how many steps you take when you're going for a walk. Now, the coffee machine, it's inside the coffee machine, there is a chip that records what settings you would like your tea or coffee. So for example, if you want 1 shot of espresso or 2 shots of espresso, this machine would know, just so you do not have to manually input in each time you make your coffee or tea. Okay, so my next question for you all is, which of these objects do you think are related to computer science? So I'll give you about 20 seconds. So which of these do you think are related to computer science? Okay, so this is a trick question. The answer is all of these. So the smartphone, we've already talked about the smartphone, how the smartphone is essentially a mini computer. You can use it to access apps such as the ones shown here and many more. Next, we have Minecraft. So every single video game and computer game that we've played, if it were not for computer science, none of these would exist. In fact, game development is one example of computer science. Now, computer science is just like mathematics. It's very broad. There are many subsets of computer science. We will talk about a couple of them today. Next, we have the Nintendo Switch. So gaming devices is a direct result of computer science. Next, we have the robot. So the robot is another example of computer science, in fact, artificial intelligence, which is the act of having a computer think like you and me. Now, next we have the traffic light and the Oyster card. Now, these by themselves are not computers, but both of these are controlled by a remote computer where it records, for the traffic light, it records how much time for the traffic light to take to turn from red to yellow to green. And for the Oyster card, when you top up your Oyster card, it will know how much money to take out when you go from station A to station B. Now, two additional applications of computing in day-to-day lives. One is facial recognition. Used now, on the one hand, many new mobile phones, you can use it to unlock your phone rather than entering in a manual password. Also, facial recognition is also used in CCTV as well. Now, as we're continuing to practice social distancing, it's encouraged that we cycle to work or school rather than take the subway. Now, the higher cycles, this works similarly to the Oyster card in that there is a database where it tracks which bicycle lots are open and which ones are not open, as well as where did you rent your bicycle and which dock did you return the bicycle. Okay, so we've talked a little bit about what is a computer, and we've talked a little bit about some applications of computers. Now, let's move on to the next step. So my question is, what is computer science? Take about 15 seconds for this question. Okay, so computer science is the study of computers and how we can use computers to solve problems in the real world. So using a computer is great, but we can also use computers to solve everyday problems that we may not be able to solve using our brains alone. Now, as I mentioned earlier, computer science is a very broad topic. We can have many different subjects in computer science. Three examples are artificial intelligence, which I mentioned earlier. Next is computer networks. So it's the relationship between different computers. The internet is an example of a computer network. Another example is cybersecurity. So how can we keep our online accounts safe from hackers? Now, these are just three examples of computer science. In fact, my interest is in artificial intelligence, and I'm currently writing my dissertation project, which is my end of degree project on a subject in artificial intelligence. Now, taking this to the next step, what do you think is a computer program? All right, so a computer program is a set of instructions that you give the computer to complete a given task. So think back to the definition of a computer, where it not only stores information and data, but it can also perform different tasks that are based on instructions that you give to the computer. Now, these instructions are called a computer program, also called an algorithm. So a computer program is a type of algorithm where an algorithm is just a set of instructions that you will give a computer. Now, the term writing a computer program is very wordy, so you use coding for short. So if you hear someone say, oh, I'm coding, or I'm writing code, that is a shorthand way of saying that you're writing a computer program. Now, next question, true or false? When coding, we can write instructions in the same way that we can talk to our friends. So for example, let's say we want the computer to print out the lyrics of the Happy Birthday song. Would you just tell the lyrics as if you were to teach a friend? The answer is false. So again, a computer is a machine. A computer speaks in a language known as binary, which we're not going to talk about today because of time, but a computer cannot understand everyday languages such as English or Spanish or French. We have to communicate with the computer in a way that the computer understands. Now, you are going to learn different computer programming languages in your computer science course, but these are just 3 examples of computer programming languages. We have Java, we have C++, and we have Python. Which program is the best? Again, that is entirely up to you. Every single computer program does the same stuff. The only difference is that the notation might be different. So for example, one language you might use brackets, whereas another language you might not use brackets. So what I have next is an example of a real computer program. So this is a program that I wrote. It is written in Python, and this tells the computer how to print out the lyrics of the Happy Birthday song to my friends Fred, Lucy, and Elmer. Now, at first glance, this looks like a bunch of gibberish. And when I first started learning how to code, when I first saw this, my first reaction was, what on earth is going on here? Now, we're not going to talk about the notation today because of time, but in your computer science course, you will learn how to communicate in a way the computer understands. And a lot of this is a set of rules. Now, you'll notice that this is not, it's a little bit different than how we would speak to our friends. And if I were to run this into my computer, it would print out the lyrics of the Happy Birthday song to Fred, Lucy, and Elmer. Now, does the order of commands matter in a program? The answer is yes. A computer reads each command line by line. So again, as I mentioned earlier, a computer is a machine. It reads each command line by line. So let's say if I were to change the order of the first chunk, the DEF happy, and then the second chunk, it would give you a completely different result. Now, if I were to write a program and I do not pay close attention to the order, 2 things may happen. One, it will give you a program, but it will not give you the program that you want. It might do something completely different from what you want it to do. Or even worse, you might just get a big fat error message where you have to go back into the computer program and figure out, okay, what is causing this error? And that is called debugging. Now, sometimes you may want to change a computer program for the good. So let's say we want to write a program that wishes you a happy birthday. So instead of rewriting the entire program, what you can do is you can open up a previous version of your program. And what you can do is we can replace Fred, Lucy, and Elmer with your name. So this is an example of the command that you would type in for a person in James. So again, the for person in, we're not going to talk about today, but this is just an example of a notation that you would use in Python. Now, these are some additional links to learn how to code. The first link is based on Khan Academy. Now, Khan Academy is really good for a variety of different subjects. This goes really into the nitty-gritty of what is computer science, as well as some coding exercises. The second link I really like, it's a Minecraft code where you get to play Minecraft, but you're coding, which is really cool. Okay, so we are now going to shift gears and we're going to talk about potential career routes for computer science. Now, why choose a career in computing or IT? Jobs in computing are well paid. There's also a large variety of types of jobs available, which we'll talk about in the next slide. Now, as an example, the median salary for an IT engineer, where an IT engineer is just one of many jobs you can pursue with a degree in computer science, is £32,872 per year. The link below will show you some additional examples of jobs that you may take in computer science, as well as their median salaries. Now, because computer science is such a broad subject, you can use it in a variety of different fields. So for example, if you're interested in working in healthcare, you can use computer science in healthcare. Are you interested in transportation? Computer science can also be used in transportation, such as Oyster Card. Also, if you're interested in banking, or if you're interested in exploring space, or if you're interested in games or apps, or watching or learning more about how Netflix is run, all of these are graduates of computer science can work in these companies and many more. Now, any single company you can think of, chances are there is a application of computer science in those companies. Here are some additional sample jobs. So as I mentioned earlier, game developer. A game developer is someone who develops computer games such as Minecraft. Next is database administrator, information systems manager, software engineer. Now, a software engineer is someone who creates apps. So all the apps that we know and love, both on our computers and in our smartphones, if it were not for software engineers, none of these apps would exist. Another example is data scientist. A data scientist is someone who looks at patterns of large sets of data that we can use a computer to help us organize the data. Now, this link below, this link will give you some sample jobs with a computer science degree. So what are the entry requirements for computer science? So for A-levels, to get on a computing-related degree, you usually require at least 2 A-levels or equivalent. A lot of top universities require at least 3 A-levels. Now, something to take note, different universities have different entry requirements. So it is extremely recommended that you do your best on all of your A-levels. Also, when you're applying for university and you're interested in studying computer science, definitely look at each university's website because the requirements may be slightly different. You'll also need at least 5 GCSEs, including science, English, and mathematics. And the link here, this link tells you the requirements for a bachelor's degree in computer science at University of East London. Again, which university you're thinking of applying for, it all depends. It might be completely different, so I'd recommend going on to that university's website as well. So some courses will ask for 1 or more of the following A-levels, in particular mathematics, computing, computer science. If you're interested in studying computer science in university, it is advised to try and do well in mathematics particularly. And if your school offers computer science as an elective, I recommend that you take that elective class because the more background information you have early on, the easier the transition will be when you start your computer science course. And if your school does not offer computer science as an elective, that's okay. Mathematics is really good, as well as the links I provided earlier on background to computer science. Now, in your computer science course, you will be taking a list of modules. Now, a module is a class that is taught by a lecturer and is also run by a tutor as well. So it's not just computer science. Every single course in university, you will take a series of modules. These are the modules that you will take as a first-year student studying computer science at University of East London. So information systems, modeling and design, software development, maths for computing, computer systems and networks, and web technologies, and mental health, professional life. And the link below shows you the modules you'll take in your other years as well. Now, again, each university offers different modules. So, for example, the modules offered at University of East London might be a little bit different from the modules that a first-year computer science student will take at Middlesex University. So I recommend that you look at the university's website so you'll see which modules you'll be expected to take in each year of your computer science course. Okay, so we've talked a bit about what is a computer. We've talked a little bit about what are some examples of computer science. We then talked a little bit about what is a computer program. We even looked at an example of a real computer program. And then we talked a little bit about what are some applications and jobs you can pursue with a degree in computer science. Now, the last thing we're going to talk about today are the best and worst things about being a computer science student. Now, this is entirely personal. So this is from my point of view. This is not, the best or the worst things. Again, each person is different, but these are just from my personal experience. What are the best and worst things about studying computer science? Now, one, which is both a plus and a minus, is coding. Now, I do not have a traditional computer science background because I received my first degree in physics. So I had to teach myself how to code, and I also learned how to code during my current course in computer science. And as I mentioned earlier, when I first saw computer programs, my first reaction was, what is going on here? What are all these symbols? But I learned it relatively quickly. It's just like learning how to ride a bicycle, where once you know it, you never forget it. And you'll realize what each symbol means. Now I learned that it's very concrete and it's very logic-based, which is something that I've grown to really love about coding. Now, something that continues to be a challenge is fixing and finding errors. Now, even experienced computer programmers, after they complete a program, they will notice that you'll either get an error or it will not give you the information that you want. And that is okay. What we have to do is we have to find and fix what those errors are. And it's hard at first, but it is part of coding. And the best thing is, once your program works and once it does what you want it to do, you feel a lot better after knowing you spent that much time on debugging that program. Now, another feature is group work. Now, regardless of which course you choose to study in university, you will be required to work in groups. You'll be required to work with other students in your course. Now, one potential downside is that you may find that students will be working at different rates. Some might slack off or will not cooperate. And to get around that, what you can do is early on, you can assign roles to different students in your group. It also forces you to learn how to delegate and support, as well as the ability to adapt to various people and different learning styles, and team building. Now, more employable. So you will be working in groups, not just in school, but also in the workforce. So these teamwork skills that you learn both currently and in university, these skills you will use in the workforce, regardless of which career you choose to pursue. Now for a quick recap. So we learned what is a computer and what is computer science. Next, we learned about the definition of a computer program. Next, we learned what it's like to be a computer science through a computer science student's perspective. We also talked about some careers that computer science can take you into, next, we learned a little bit about graduate pay. And finally, we learned some entry routes to get into a computer science course. So that concludes the webinar for today. And thank you very much for participating, and have a wonderful rest of your day.